So all you have to do is make sure you pay attention, right? So grab your calculators. I'm gonna have mine ready. And before you start, I think you already know this, but it has to be set to degrees. Okay? So your calculator should have a D or DEG or something at the top. If it says rad or R, no. If it says grad, we want that at the end of the semester, but right now we don't want that, right? So gradients, radians, you don't want that. If you need help changing it, call me. I'll help you out. If you're still not sure, just go sine of 30. Go sine 30 or 30 sine, whatever your calculator. You should get 0.5. Then you know you're in the right setting. Okay, let's go. So trigonometry. What's your math teacher's favorite tree? Trigonometry. Cheesy. Anyways, make sure your calculator is set to degrees, no grad or rad. And also, make sure you write this down. Don't use, I don't know if this means anything to you. This is how I would teach it in grade 10 and 11. SOHCAHTOA, right? Sine is opposite hypotenuse. You don't use that anymore, okay? Exclamation mark, okay? Does it still work? Yes, it still works. But the requirement of this has to be a right triangle. Most of our triangles are not going to be right triangles, okay? So what I had in the past, I had a lot of students. This looks like an N, right? It's supposed to be an H, sorry. But don't use it. Don't use that. I had a lot of students freeze on the exam when it came to trigonometry, and they would revert back to what they learned in grade 10 and 11, SOHCAHTOA. And it's all wrong. Like, you can't use it. So I'm just going to say don't use it. Sine law, cosine law is all we're going to use. Okay, so basically, we're going to start with sine law or cosine law. Those are the only two tools that I'm going to teach you about. They allow you to solve for any triangle. Okay, oblique, right, doesn't matter. They can handle it. Okay, so that's some good news. So if you struggle with SOHCAHTOA, hopefully this will get you out of that. A few things that I need to review, and I'm warning you, today is going to be a lot of review, so try to still stay with me because this is going to come up quite often. Okay, so isosceles triangle, equilateral triangle, and a right triangle. Okay, so those are the three types. It's going to come back in a different unit called geometry. Okay, an isosceles triangle has two sides that are congruent. Two sides are congruent. What is that? They're the same. Okay, this is the symbol for congruent. It's an equal sign followed by a third wave. Okay, and now I'm having flashbacks sitting in my basement teaching from my basement when I hear waves. It's the second wave, third wave. Anyways, and then two angles are congruent. Okay, it's very important that you should right away know, okay, that's what isosceles means. So guess what? It's not any two. If these two sides are the same, guys, it's the angles across those two sides that are going to be equal to each other. Because it's not always going to look like this. Sometimes it's going to be upside down. You just look for this side. You're like, oh, that's 30 degrees. Well, guess what? If this side is the same, then I'm counting on another 30-degree angle on this side, right? So that's how I want you to think of it. Equilateral, I think we all know that one. All three sides are the same, and all three angles measure the same as well. Three sides are congruent, three angles are congruent. This is the symbol for angles, right? It's just like that. In fact, what is each angle is always going to be? Anybody remember how many degrees if they're all the same? 180 degrees is all three. 60, right? Some of you remember, some of you need a reminder. Here it is. It doesn't matter how big or how small a triangle is. If all three sides are the same, guaranteed 60 degrees all around. And then you've got your right triangle. That one, I hope you recognize. It means it must have a 90-degree angle somewhere. Okay, it could be upside down like this. It doesn't matter. This is basically, my three types. When it comes to right triangles, okay, I want to quickly review Pythagorean theorem because it does show up from time to time. What's the one called across the 90? Hypotenuse, yes. I don't know if you've seen shirts with a hippopotamus on this one. There you go. And we're going to call this leg and this one leg as well. Okay. So the across the 90 is your hypotenuse. The other two are called legs. And you're like, Mr. Isfeld or so-and-so, Mr. Slavinsky, whoever you had, said opposite over hypotenuse. That's only when you're using SOHCAHTOA. But when you're using Pythagorean theorem, we only have hypotenuse and technically the two legs. So copy this down. In order for us to find the hypotenuse, we're just going to take the root of the leg squared plus the other leg squared. That's as simple as that. Okay? Or if you're missing one of the legs, if that's unknown to you, you will go leg is equal to root of the hypotenuse squared. It's very important that you start with the hypotenuse and you take the other leg that is known away from it. So these are the two formulas that I would like you to, it's going to come back when we do geometry, these two formulas, okay? I know you're used to ABC. I know that. A lot of your A squared plus B squared is equals to C squared. But what if I put the C in the leg? You're going to be like, what? That's C, but that's supposed to be the hypotenuse. So I don't want you to fixate on letters. I want you to just remember this, okay? How many sides do you need to know if you want to use Pythagorean theorem? You need 2 out of the 3 known, right? And then you can find a third. So hopefully that makes. And if you're like, what? I will use this again. So we'll come back to it. All right. Sum of interior angles is always 180 degrees. Shortcut. I will sometimes say sum of triangles is equal to 180 to refer to this property. It doesn't matter what it looks like. The triangle could look like this. It could look like this. It doesn't matter. A, B, C. A, B, C like that. No matter what, if you were to add those 3 angles, you always have to get 180 degrees or else it's not a triangle. That one I'm pretty sure you remember, and here is the one that's going to come up again and again. Supplementary angles, right? That is saying that 2 or more angles whose sum is 180 degrees. That's basically what I want you to remember. And so we're gonna, a lot of you told me I like visuals, I like diagrams. That's how I learn best. So let's try that. So imagine if you have a ruler, you can use that. If not, just use something to create a straight line, right? So you always want to think of a straight line. If you were to cut it anywhere along that line, if you make a point right there, now you've split it into 2 segments, right? If you were to measure the angle from this side all the way to the other side, how many degrees would it have? 180. That's right. So, and now imagine I come along and I create this problem. You go to that dot right there, and just anywhere you want, I'm going to go over here, you slice that up. Okay? And let's say you're like, I know this is 30 degrees here. You should automatically think, oh, there's a straight angle right here. So this over here is going to be 150. Okay? And I want you to focus on, always try to think of, hey, there's a straight line right there. It's 180 along that. Okay? How is that going to come up again? I will do without a ruler so you can copy me here. I'll just go off like this. There are instances, and once you start reviewing, I will show you that, or we're going to come across these. There are some instances where you see a triangle like that, and the question will give you the angle outside there, okay? And you're gonna be like, oh, solve this triangle, like how? There's no angle inside the triangle, but you're gonna be like, I can tell that I can bring one inside because I see the straight angle there, so that means that this has to be 60, right? And now you have an angle inside the triangle, you just go for it and solve, okay? I forgot to add complementary here. So make sure you add this. Complementary angles. The sum is what? Sum is 180. This is 90. Okay. Think of it this way. 90 is right. It's right to complement someone. It's the right thing to complement someone. So you're like, oh, right, complement. 90 goes with complementary. Okay. If that helps you, it does. If it doesn't, hey, we tried, right? Complementary would be something like this. You have a scenario where there's a 90 there. You know it's a 90 there. And it's cut by this angle, which is, let's say, 50 degrees. Then you should know that that is 40 degrees, right? Because we have a 90 formed by the two lines on the outside. To be continued. I just want you to know, right? Let's keep going. This one right here, you need to know how to read angles. So I'm going to make sure you understand that. For angle notation, you need to be familiar with the three-letter notation. Okay? So all of these here have the angle symbol in front of it. Okay. So what we're going to do here, come with me to this diagram over here. So we're going to add some letters to it. I will go this angle here, I'm going to call that X. I'm going to call this one Y. I'm going to call this one Z. I'm going to call this one K. And this one up here is just going to stay angle C. Right, I'm just going to keep that way. Okay, so you're going to have to do this right away. I'm going to show you one. Angle ABC, where would that be? Read it exactly the way it's written here. So you go to A, right? You start there. It's almost like a dot there. A, B, C. So it's this angle that is formed by connecting A, B, and C. So almost imagine you're connecting those dots, and that angle is what you're looking for. So angle K is the one you're referring to. And trust me, once you are able to do this, right? If you don't like to deal with the 3-letter notation, you're like, you know what, I'm going to call that angle K. You go to your diagram, you put that down, you no longer have to deal with angle ABC, because this is kind of painful sometimes to deal with it. So I want you to try and put the letter that belongs next to the equal sign. Do that right now, and then we'll correct it together. Let's see here. CBD, where is it? Let's connect. CBD, Z, yeah. CDE is X, yes. And BDC is Y. And I hope you understand you couldn't just use, hey, find angle D. You're like, well, there's 2 angles at that point, so you can't use just this letter here. You need to narrow it down using 3-letter notation. For sides, we sometimes have 2-letter notation. So if it's asking for BC, right, you're wanting this side right here. Let's put a number 1 there, and we'll just say that's number 1. DB is down here, put a number 2 there, and DC is this stretch right here. We'll put a number 3 there, and we're good to go. Trust me, it won't be your first time to see that 3-letter notation. I just want you to be aware of that. Let's keep going. Lots of review before I actually dive in, okay? Okay, I will say that this is not always what I follow. I sometimes go off of it, but in general, we use caps for angles, lowercase for sides across from the angle. So for example, sketch triangle XYZ. And you're like, okay, we have no idea what it looks like. It's safe to assume that it's not going to be symmetrical. So I'm going to go up like this and make it longer on this side and then close it like this. So it's not perfectly centered, it's off-centered, right? You choose where you want to start. I'm going to go capital X, capital Y, capital Z, like that, X, Y, Z. Some teachers go clockwise, some counterclockwise. It doesn't really matter. And then we say, okay, if this is angle X, then across from it would be side X. So if I asked you, it's like solve for side X, with this triangle, you should automatically know I'm looking for that side. This is side Y, and this is, the only way to do lowercase for me is to make it smaller. That's all I can do here, right? And so that's what I expect you to know. You want to go arrows like that. I'm not sure if that's going to help you, but that's how we label in general, okay? And then moving on. Yeah, this one. I know you should have heard of this before, but here's my attempt to making sure you understand the difference between the two, okay? So maybe watch me first. So imagine this is a person, and this is your line of, this is straight eye level. Okay, this would be eye level. If you see something, if you were to look at the ground and you see something crawling on the ground, it's supposed to be a bug, right? You would measure the angle to this from the horizontal going downwards like that. That's very important. There's always a horizontal, and that's when you start measuring. So this angle formed between these two lines is the angle of depression. Okay. If you now see something up in the air, so let's say it's a bird, Okay. Now you're going from the horizontal, you're measuring upwards like that. And so this is your line of sight going up. The measurement from the horizontal going up, this is the angle of elevation. One of the most important concept, the most important concept here is that you should always have a horizontal. Okay. This is what I call, right? And I will actually add that to my notes right here one more time because it doesn't hurt. Always measured from horizontal. Always. I will give you two examples here. Example, the angle of elevation to the top of a tree is 40 degrees, let's say. Can you see that? Angle of elevation to the top of a tree is 40 degrees. You should be imagining a triangle where the ground is your horizontal. This is my tree, right? And so you would be measuring from the ground to the top, and that's where you would place the 40. An example for depression, you would say pilot sees the airport at an angle of depression of, let's say, 25 degrees. If you see something like that and it says angle of depression, you should be picturing, sorry guys, this is, I'm not artistic as you can tell. There, pretty good. It'd probably crash if I built it. But you need to imagine, right? There's a horizontal. This one is imaginary because you're up in the air. You're up in the air. There's no ground to measure from. And then you would kind of say, okay, well, from here to here, where the airport is, let's call this A, that line, the line of sight going to the airport, the angle of depression would be placed right there. Error, the most common error here is this. Students want to put the 25 here, and this is wrong, okay? Wrong placement to put it there. It's always between the horizontal and the line of sight to whatever, okay? Could be in a hot air balloon, anything like that. If you're looking down, angle of depression is measured from the horizontal looking down, okay? An eagle sitting on the edge of a cliff or top of a mountain, whatever. One last thing, keywords down here. You know your compass rose, I'm hoping. North, south, most students are pretty comfortable with where north and south is. The east, west, no, not so much. Okay, so it's supposed to, I know your teachers tried a bunch of things. Never eat soggy wieners, you name it, right? I just always tell my students, make sure you read we, not you, right? If it's EW, it's you. North, south, I think most of us got that, but just want to make sure it says we. Okay. So example, why is this important? If it says a tree is due east of you, right? If you see that due east of you, that means that this is you, and the tree would be due east of you, right to the side here. So this is where the tree would be located. This is east. Right? So there you now have a reference as to where to place that object on your diagram. Okay. Another one. This is the last one for review, then we jump into our lesson. What did I want to say? Oh yeah, if you write this down on page 3, right? If you walk at 7.5 kilometers per hour and you travel you hike, I should say, or whatever. You hike for 4 hours or 4.5 hours, right? How far have you traveled? How far have you hiked? And this is, sometimes they give you this to find the total distance. So all you have to do here is distance is going to be speed multiplied by time. So distance is 7.5 multiplied by 4.5 hours. I just made this up, so I need to look this up. 33.75 kilometers you will have traveled at that. And I think this is pretty, it's just common sense, right? If you travel 100 kilometers per hour and you drive for 4 hours, 4 times 100, you will have traveled about 400 kilometers if you kept that speed up for the entire time. Okay. What? All right. This is it for review. Okay. So we'll take a 2-minute break, and then I'll start with sign law. That's the actual meat and potatoes